Good morning, everyone. Well, good afternoon. Hope everybody's doing all right. Everybody's doing well. So, gonna wait for everybody to get all the way in, and then we will get started today. All right, looks like everybody's in. That's getting in. So, hope everybody had a great weekend. Everybody's doing all right, ready to get into this holiday. Today I said we would do 8.2, which is the last um section for new material. Then next week when we come back, it'll be a week of review. Basically, you will look at the final exam review and everything that I'm going to post that uh, shortly, and making sure you have the review for chapter 7 and 8 as well. So you'll be able to ask whatever questions you want to ask next week. And make sure you have your specific questions. So, you talk about going into math lab, pulling the problems out. Say, hey, can we try number 8.1 on section 8.1? Wait, number one on section 8.1 or something like that, versus being, random with your questions. Make sure you come specific so we can make proper use of everyone's time and go from there. And then, of course, office hours will still be in play as well and everything like that. So, let's go ahead and knock out 8.2, and then if anybody else have anything or any other questions or clarity, then we'll make sure we get those taken care of before the session is out today, and then we'll go into this Thanksgiving holiday. All right. So 8.2 is estimating population means. So using a sample mean to estimate the population mean, suppose that we have computed the sample mean for a single sample drawn from a large population to estimate the population mean. And so that's basically what we're doing. We're going to use uh, sample information to estimate the population mean or the population average. So we're going to use a sample mean as our best estimate of the population mean. And then we're going to compute a margin of error and use it to construct a confidence interval around our estimate. And that's going to be based on the sample size, the standard deviation, and the mean from the sample. Okay. All right. So next thing we bring up is the confidence interval. It's going to be a range of values likely to contain the true value of the population mean. Anybody holding on to that orange box or beige, whatever color it is? All right. So in this book, we will work only with the 95% confidence level. Although there are other levels of confidence, they have 90% and 99%, but we are only going to use a 95% confidence level. All right, let me scroll up. As always, if I scroll up too far, somebody still copy and let me know. So here we're looking at the margin of error with the 95% confidence level. So when we use a sample mean with an estimate of the population mean, the margin of error for a 95% confidence interval is going to be 1.96 times S over the square root of N. So that's 1.96 times the sample standard deviation over the square root of the sample size. Mhm. So, that 1.96 comes from the 95% confidence level. If you look down here at the last statement in the box, it lets you know that, if you were going 90% confidence level, then you would replace that 1.96 with 1.645, or 99%, you replace it with 2.575. But once again, we're doing 95% confidence level, so it's going to stay at that 1.96. But that's where it comes from, the 95% confidence level. Scrolling up. So when we look at creating this confidence interval, what we're going to do is first calculate the margin of error. Then we're going to add and subtract it from the sample mean. So you see what we have right here, just a little diagram of how it would be set up. Our confidence, not a confidence, but our sample mean would be in the middle. And if you add your margin of error, you create a number, then subtract your margin of error. That will be your lower number, and that will create your confidence interval. The smaller number, the lowest number. So what you're saying is, to estimate the population mean, it would be in between these two numbers. We're projecting or estimating that it would be in between these two numbers. Scrolling up some. And then here, this last box is re-emphasizing what we just mentioned. To calculate your confidence interval, you're going to add and subtract the margin of error from the sample mean to get your two numbers that you're confident that the population would be in between. All right, first example, consider the daily protein intake data described above for a sample of 267 men. So when they say above, there was an example, a storyline that was given before the example, but we didn't need that for this. So with the sample mean of 77 grams and a standard deviation of 58.6 grams. So find the margin of error for 95% confidence level and construct the 95% confidence interval. How does this interval compare to the recommended daily protein intake for men, 55 to 60 grams? All right, let's scroll up. All right. So whenever it comes to a word problem, I always like to write down a given piece of information first. So in the purple, it's just me rewriting what we had or what was given to us. They give us the sample size is 267, sample mean is 77, and then the sample standard deviation 58.6. Now I need to find the margin of error. That's the formula there. 1.96 S time divided by the square root of N. So you throw that in the calculator, 1.96 times 58.6 divided by the square root of 267. And it gives us 7.0291, rounded to 7.1, because that's what the example called for. So make sure you pay attention to MATLAB and how, what decimal places they will hold you to. In this case, it was just one decimal place. All right. So now that you have your margin of error, you add it and subtract it from the sample mean. So sample mean is 77. So 77 minus 7, which is 70. 77 plus 7, which is 84. Anybody hold on to the word problem? Let's scroll up. All right. So our population mean should be in between 70 and 84. All right. Okay. And then this blue statement just in reference to the last question they asked. So the results suggest that American men are consuming a significantly different amount of protein than the recommended daily allowance of 55 to 60. So this is their recommendation, but this is what we calculated. So that's why it's significantly different. All right, everybody done with this? Let's go up. All right, next example is very similar to what we just did, but just want to make sure we were okay with the process. Studied by the University of Maryland, researchers investigated the body temperatures of 106 subjects. Sample mean of the data is 98.2 degrees Fahrenheit, standard deviation, 0.62 degrees Fahrenheit. Estimate the population mean for the body temperature with 95% confidence interval. All right, so just like before, 106 is our sample. In other words, I wrote down given information over here, just like before. But 106 is our sample, 98.2 is our sample mean, and then 0.62 is our sample standard deviation. Our margin of error, 1.96 times S divided by the square root of N, 1.96 times 0.62 divided by the square root of 106. Ultimately, that gives us 0.12. Once again, make sure you pay attention to the directions and how MATLAB wants you to round your decimals. Then once you have your margin of error, in this case it's 0.12, we're going to add it and subtract it from your sample mean. All right, let's scroll up. So subtracting 0.12 from 98.2 will give you 98.08. Then adding 0.12 to 98.2 gives you 98.32. All right, and to finish that one off, just our mean should be in between 98.08 and the 98.32. All right, question before we look at the last thing. All right, so now we're looking at how we would be able to choose a sample size based on the margin of error that we want to achieve. So in order to estimate the population mean with the specified margin of error, at most E, the size of the sample should be at least, and they give us the formula, 1.96 times the standard deviation over your margin of error squared. All right. Yeah, I'll get with you. I'll see what you are referring to once we let class out. Yep. All right. So can we scroll up? So here we have our last example for the day. You want to study housing costs in a rural county by sampling recent house sales. Their goal is to provide 95% confidence interval estimate of the housing costs. Previous studies show or suggest that the population standard deviation is about 7,200, for a sample size at minimum should be used to ensure the sample mean is within. First one is 500 of the true population mean, and then B is 100 of the true population mean. All right, let's scroll up. So once again, I'll start off with listing what's given. So they gave us in A, they gave us our margin of error. And so notice it says within 500. So you're talking about adding 500, subtracting 500. And then our standard deviation is 72. So that's where I got this from. And that's all you need in order to be able to calculate the sample size that you would need in order to create these this criteria. That's 1.96 times 7,200 divided by 500 squared, which gives us 796.6. And notice I rounded to a whole number, and I'll show you the statement that says why you should round to a whole number in a second, but just give you a chance to finish copying. All right, can I scroll up? So you see a statement in blue because the sample size must be a whole number. It must be a whole number because remember, you're talking about sample size, you're picking out objects, so you're picking out people or something along those lines. So those would be in decimals. So if you chose 5 men or you chose 5 people out of the population, they will be whole people. They would not be decimals. So because the sample size must be a whole number, we conclude that the sample should be or should include at least 797 prices. Around at 796.6 to 797. All right, questions? We'll go to the next one. All right, so the next one we had the margin to be within $100. What the population means to be within $100. So our margin of error is 100. Standard deviation was still 7,200. So that's 1.96 times that 7,200 divided by 100 squared. And then ultimately they give us 19,915. All right. Questions, questions, questions. Everybody good, everybody fine with what we've done. All right. So that is it for 8.2. Those are the examples that what type of problems you will see in the section. So some questions may not come out until you try them out. So make sure you do try these out. Between today and tomorrow, there will be the rest of your assignments and reviews posted. You know, they'll prep you for the rest of everything that we have going on, and of course the final exam review. And so next week, when we come back, it will be, you know, both classes will be opportunities for you guys to ask whatever questions you want to ask, and also office hours are available as well. And then the week after that, you will be your final exam. It'll be time for you to take your final exam. Also, before the week is out, I'll send you the final exam scheduling. Remember, I told you I will give you multiple days to choose from, in which you know, all you would do is, and all the instructions will be on your on the email that I sent. And you just, you know, choose it. You don't have to tell me which day you're coming in. You just choose that day and just come in, and then show your, you know, make sure your camera's enabled, show your ID. I'll give you the password, take the test, and then go from there. All right. So any questions before we close out? Everybody good? All right. So you guys have a good one. Be safe. Have a great weekend. Have a great holiday. And I will see you on Monday. Sydney, when did you send that email? So that I happen to get the email. Let's see. Okay. Oh, you said it this morning. I haven't looked at my email this morning. So more than likely I got it, and I'll respond before the day is out. Yeah. I thought you were saying like you were sent a couple of days ago. But yeah, you should be fine. Yeah, no problem. Not a problem at all.